Last week we looked at the motivation or the reasons why we need to look at dimension reduction. Okay, the more the predictor variables, the larger the dimension of the data set, and more observations will be needed to have a good prediction capability. And we looked at several strategies, removing and combining levels within a categorical variable, and removing variables that are not very valuable in terms of predicting capability, and variables that are highly correlated, multicollinearity, and things like that. So um, we're going to look at some of those mitigation strategies for dimension reduction in the rest of this chapter. So one of the first things we need to do is to look at the data, look at the summary, data summary, and look at the correlations to figure out which variables are important, which variables are not important or useless variables that can be thrown away. And we need to do all that in consultation with the domain experts, obviously. And one of the tasks that we need to look at is whether the data, whether any variable has uh, errors. If a variable has lots of errors, then maybe you're better off throwing that variable out. And a couple of other practical considerations are whether a given predictor, is it possible to measure the variable in the future. If you're not able to, suppose if you're gathering information that is out of date in terms of collecting ability, so if the technology is not available or something. So like for example, how many people use cassette tape or something, so which is out of date. So we can't have that information in the future. So whether a variable can be measured in the future or not, that should be a consideration to include a variable. Um, and whether a variable can be measured before the value of the target variable is determined. So if that's not so, then we will not be able to use it for prediction. For example, if you have auctions and the data for the auction contains lots of variables along with how many bids there were and then what the auction price was. And obviously, how many bids were there can be known only after the auction has been completed. So, in which case, you will already have the closing price and there is no need for prediction. So, closing price of an auction cannot have number of bids as a predictor because of the timing problem. Same with taxes. So you have home price and taxes. So taxes come from home price. So you won't have the tax ahead of time for us to be able to predict home price with that. So these are some of the considerations that we need to look into. So for the first few, like whether a variable is important or not, whether it is useful, whether there are any errors, we look at summaries. And we've already seen some of the summaries that we have done previously. So let's start with uh, reading the data in. So we're going to use Boston housing data. Okay, so we're going to read that. Okay, and then we can use summary BHTF, and that's going to give us the 5-number summary. So 5-number summary is minimum and maximum, first quartile, third quartile, and the median. And of course, it gives you the mean as well. The 5-number summary is just the minimum, first quartile, median, third quartile, and maximum. It gives you the mean as well. So we've already seen this several times, and this will give us an idea about the range of data, and we can look at the minimum and the maximum and see whether they seem reasonable. Now, for example, if suddenly you have age as 300 or something, then we know that there is a problem with that value and how many errors there are and things like that. Now we can also go beyond these 6 measures. So we can compute standard deviation, okay, how many there are, length. So these are some of the functions that we can use. And we can also use what is called quantile, and we have not seen that in more detail. So here is how quantile works. Quantile is how we compute percentiles, the 5th percentile, the 15th percentile, the 90th percentile. Percentile briefly is what? You take a data column, okay, and then you sort it from the lowest value to the highest value, okay. So once you have sorted it, percentile is what percentage of data starting from the top, okay, you need to go in, and then what is that value. So 5th percentile will be starting from the top, you go 5% of the way. So for example, if you have 100 observations, so 5% will be you go 5 observations down and then see what the value is. That's your 5th percentile. So 50th percentile will be you go down to about half. So that will be the median. 50th percentile is the median. And then if you want 95th percentile, then you go from the top all the way down to the 95th position. So that will be one of the larger values. So what value is occupying that particular position? That's your 95th percentile. And you can get these percentiles using quantile. So we can use quantile to compute percentiles. Okay, let's see how we do that. Quantile. Okay. Now, this is the syntax. So you have to give a numeric vector first, and then we specify the probability. Okay. 5th percentile will be 0.05, 95th percentile will be 0.95, and things like that. So here we can say bh.df, and you have to specify one particular variable. Quantile will not take a complete data frame. And then you say that I want the 5th percentile, right? Then you run that, and I have an error here. Quantile is misspelled. Okay, so it gives us the 5th percentile. Now if you change that to 95, so it will give you the 95th percentile. Now if you want several percentiles at the same time, then you can specify a list. Okay, so like that. So if we want, say, the 5th percentile, the 10th percentile, the 90th percentile, and the 95th percentile. So it will give you all of those percentiles. Okay. Now, if you want percentiles, okay, for a whole bunch of variables, right? So this will only compute the percentiles for one predictor at a time. Okay. What if you want for several? Okay. So let's say I'm going to build 3 measures: mean, okay, 5th percentile, and 95th percentile, and construct a data frame, and I want it for all the variables. Okay. So now if I say S apply, we can use S apply. That will go ahead and apply for all the columns. So here BHDF, and then I say mean, right? Then for each of those columns, this function mean will be applied, and you'll get the mean for all of them. That is great. But we can't do that with quantile. right? So we can do s apply bh dot df and then say quantile, because quantile needs as the first argument, it needs a vector. Okay, now this is an entire data frame, and the entire data frame can go in there. So what we have to do is to set up a function. So s apply, so here is the data, and then each column of the data will be applied to this function. So we can specify our own function. It need not be one of the function that is available in R. So we can say, all right, so this is the function into which these columns will be applied. So each of these column will go in, okay, and that column will take on the name X. And then we can say quantile, all right, X comma, so if I say 0.05, then that is going to give me the fifth quantile. Okay, so now I have the mean, okay, up to here, and then I have the fifth percentile here, and I can repeat that for 95th percentile. Now you can do both of them here by giving it as a list C 0.05 comma 0.95, but then that creates the data in a list format, and it becomes a little harder to print and stuff like that. So let's do it this way. So we're going to do these three things one at a time, but remember, we want that as a data frame. So what we need to do is to say, so select summary, right? And we want that as a data frame. Okay. Now, and then complete the parenthesis, and this will create a data frame for us. Okay. Now, this did not work because these three lines of code are now, okay, is messing. So you need to have a comma, okay. So they will all be part of that single line. Okay, so we have just one line of code now, and so without that comma, it will be separate lines. Okay, so no, that creates the summary, but the column names are really crazy. So we can specify column names by putting it in front of each of those functions. So we can say mean equal to, and then this one can be %5 equal to, and then we can say %95 equal to. Okay, now that's going to use these as the names for those three columns. So you run that, and now you see the names are nice. Okay, so that's how you will collect summary information for all the numerical columns and whatever summary information you like. Okay, you don't have to just, the summary function will only produce these 6 statistics, but here you can keep adding more statistics if you like standard deviation or whatever else that you want, other percentiles and things like that can easily be added here.